Hey everyone, welcome back to the workshop. Today we are jumping back to the FoxAlien Masuter 3S and we're going to do a bit of an upgrade. So originally this came with this little 500 watt spindle built into the machine, works through its built-on controller. And then as you see here, we have a trim router, basically a Bauer trim router. Well, we have the FoxAlien 1500 watt spindle upgrade kit, and we're going to be installing it on this machine, seeing how that process goes, and then giving it through a few test cuts to see just what this upgrade can make for this machine. So if you're interested in this upgrade, want to find out more, stay tuned. I'm going to jump right into it. All right, so let's first take a look at what comes in the kit. Comes in a nice box, well packaged, and let's open her up. You got a top layer of foam, and first off, we do have a user manual. Now in here, I'm told there are some critical steps that you want to read through this before powering it on. All right, so there are critical parameters in here on page 7 for the English manual, and we need to change $30 to 24,000 for the max RPM reference, and it looks like $32 0, which is the spindle enable and the function. It's a mode selector, so we need to do that. And then they talk about you need to make sure you reset $32 if laser engraving has been used before. So $32 equals 1 apparently has the risk of motor burnout, so you want that to equal 0, and failure to do that, it says, will void the warranty. So make sure you look through this before you actually power everything up. So besides the user manual, we do have a set of wrenches, and that's going to be for the collet. They're going to be your typical, looks like 14, 13, 15, and 17. So pretty typical for an ER11 collet. Have a power cord for the VFD. This one's just the US-based 3-prong 110 volt plug. And then we do have the, looks like the spindle PWM cable. So it's got the aviation connectors. We're gonna need to feed this through, and then there's also, signal wire there as well. So that's power and signal for the spindle from the VFD, and then I believe this plugs into the control box. Other than that, on this side, we do have our spindle motor. It's a pretty nice, hefty spindle motor. So it is etched with the FoxAlien logo there, with some basic specs: 110 volt, 8 amp, 1500 watt, 400 hertz, and 24,000 RPM. Air cooled, showing the direction spinning this way. Up top, you got your aviation connector on there, and on bottom, that ER11 collet as well. So pretty hefty, a lot heavier than the stock spindle, a lot bigger than the stock spindle here. So pretty good height difference. This has a thinner diameter, but this should use the 65 millimeter mount that came with the base machine that we've been using for the trim router. And it looks like the remaining item is the VFD control. So in a box here, it does have some anti-skid feet. I don't see that you could necessarily mount this. A lot of them are meant to mount on the wall. This is more to sit down. So we've got our connections on back. We've got our 110 volt power with a fuse there. We have our spindle and our PWM cables that go in there. And then up top, we have our control. So you've got your manual control for your speed, your run stop, and then your function and menus to go through there. And then a knob control to switch from basic manual control over to PWM control, and then our power button. That's about it. It is a metal case on here. There is a cooling fan on back. So it looks pretty stout, looks pretty good. Off on the side, basically just the same specs that we've been seeing throughout. So that's basically what's in the box. Our next step is going to be figuring out, got to pull off the old trim router, and the main part is running that PWM and that spindle cable through the cable chain. So let's get things set up, moved over there, see how that goes. All right, so first thing we need to do is get this trim router out of the way. So I'm going to slide our dust boot off. This should fit on the spindle as well. So want to keep that handy. And I'm going to get this bit out of there. Got that nice Jenny bit in there from Cadence Manufacturing. You definitely want to not damage that. And next we need to take the trim router out of the mount. So you're going to need a 4mm Allen key here. Get those loosened up. There we go. That's dropped free. And I didn't have this run through the cable chain, so it was just too short. That'll be one nice thing about upgrading from this. It's a longer power cable that actually goes through the cable management. All right, next thing we're going to want to do is get these cable chains as flat as possible. So we want to bring this all the way forward. Just don't push too fast. You want to get that feedback into the steppers. And then we're going to push this over here just to lay it down as much. Just gives us as straight a shot as possible. We may need to move it a little bit as we move it through there. But let me get you moved around and we'll start working that cable through. All right, so hopefully we'll be able to work here where we can see, otherwise I'll move you around. There are actually going to be 2 cables in here. So I've undone the zip tie, just trying not to make a big mess of this. But we want to extract our cables from here. All right, so this shorter one is your PWM cable. This is going to go from the control box. This end goes out of the laser output on the control box in the corner. This end is going to go into the VFD. This longer one is what's going to run from the VFD up to the spindle. And there are 2 different size ends there. So if you take a look at the back of the VFD, you'll notice this only has 3 pins on it. And if you look at this spindle, there are 4. So hopefully that means this is grounded for that extra pin, and then that just gets grounded to basically the body of there's a shielding cable in here, and then that should be grounded to this pin. So hopefully when it connects up to this, that stays grounded. So we know that the 4-pin end needs to end up here for the spindle. So we're going to need to work this cable into the cable chain, bring it all the way around the top, tuck it into this one, and bring it around this bottom size as well. And then we do also have this string of bundles going from the back of the CNC to the control box. So with this cable chain, you can try to fish it through. There's maybe a bit of room, but the nice thing is these are, they've got basically the lid to them. So you can just get a little kind of flat edge in here. You can pop these up and that will help you feed it through. Hopefully you don't have to do all of them. That is a way to kind of lay it in without having to actually fish it all the way through like some cable chain does have. So we are going to start, I think I'm actually going to mount the spindle first. We get our cable in there. That will kind of hold that in place. And then we'll start working it through. There we go. So we're going to bring this down just about there. I don't need it exactly where it's going to end up, but I just want it in place so it's holding the cable in the approximate spot we need it. So we're going to secure these down. Try to make sure that that isn't going to slide out on us. All right, and now we can take the 4-pin cable, and there is a pin for this little notch up top. It's the only way it's going to go in, so you want to get those lined up. There we go. Push it down, and then we'll just screw that on there. So now we need to start working this around this way through the cable chain. If you need to, you could take this off. It's going to be a 2mm. Now it'll be easier to work with this way. So, okay, we're going to pop this off. We're going to lay this in here, and we're going to pop that back on. Now we can just lay this in like that and then start snapping these back down. And we'll keep, I'm going to move this over just a little bit. We'll just keep moving through it. All right, first part's done. Then we don't want to forget to reattach our end here, so. All right, so we're going to need to get this mount off here so that we can get it started through here. And it'll also make it easier for these first ones because they are right up on that stepper. So it's going to be a little tricky. These are in there with a lot of cables. So the bundle of wires is going to make it a little bit tricky, but just take your time, get your Allen wrench down in there and loosen up the 2 screws. And we're going to need to do the same thing. We're going to have to pop these and run this cable through. So just go a few at a time here since they're kind of awkward and upside down. All right, so now with this free, we can start working on these. Unfortunately, the side to release these is on the inside. So we're going to need to just work slowly. I'm going to get the first 2 here. We'll bring this cable over here. Oh. Wrap it this way. Get that laid in there. See if I can get this front one closed back up. There we go. Number 2. I want to kind of keep it going in the same one. I'm going to take a couple more of these off. All right, so we're getting down to the wire with these end ones, and it might make sense to try to see if we can pop this out of the bracket. Get just a little more flexibility here. There we go. Now we should be able to get at the rest of these fairly easily. Just the last 2. There we go. Now we're through the cable chain. We just need to reconnect this to the end. Just make sure both snap back into place. We do need to put our top mount back on. Snap this back on. Now we'll wrestle our screws back into that pocket there. All right, now we're just on to the back side. We've got this kind of cable management sheath, and this is the easiest part because we basically just need to open it up enough to tuck that cable in and work our way through. So just going to go ahead and work down this cable doing that. There we go. We got it run through all the cable management from the machine. Now we just need to do our hookups at the controllers and such. All right, we're here at the back end of the table. We've got our cable. We still have some decent cable length here. So spindle, we want to plug into our bottom one. Again, it's keyed, so it lines up with the pins right. That key part is going to go down. So we're going to push that in and then go ahead and tighten that nut. All right, so we're going to take the other end. This is your PWM cable that's going to go into the controller. And again, find your notch. That looks like it faces down. Plug that in. And then, of course, we'll plug in our power once we're ready. All right, so we do need to plug in the other end of the PWM to the laser cable. And then you will want to make sure that the switch to the right of that is actually switched over to laser. And then, of course, plug in your USB cable. So confirm that switch is in the laser position. I know it doesn't necessarily make sense, but we are using the laser control for this spindle. All right, we've got our spindle mounted and set approximately where we need it for depth to get the most Z-axis out of it. And we have it hooked up to the control box. So we're going to start with just knob control to test this. We are going to power on the VFD. And you'll see the display light up in just a second. and it is going to say 0. So if we simply turn the knob, that has kicked on the spindle. And that is at full speed. There is some noise to it, but it's nowhere near as loud as the trim router. All right, for comparison, I'm gonna keep my microphone the same distance away. We're gonna turn on this trim router. Here's that low. And high. So for comparison, here's a decibel meter off my iPhone. First starting out with the spindle spinning up to its max speed and topping out around 82, 83. And here's the trim router topping out just around 100 decibels. All right, we are in G-Sender. We have the machine connected on COM 6. We've homed it to be sure that we're working. And we do need to make the parameter configurations as noted in the manual. So we're gonna come down here to our console, enter G-code. We're gonna go $30 equals 24,000. And that hit okay. And then we're gonna do $32 equals 0, which would be spindle enable and not laser enable. Now to check these, we just hit $, and that will run everything in this console. So we can come back up here and see that they applied. We want to go to the first one is, okay, so $30 is set to maximum spindle speed of 24,000, and $32 laser mode enabled as spindle equals 0. So that should be the two changes we need to make as far as just setting up the controller to run the spindle. Okay, so now that we have those commands in there and we've turned on the spindle, we can go ahead and test that the spindle is responding to commands within G code. So if you come down to your console and type M3 space S, and we'll put the speed, so let's just say 5,000, and hit run, it should turn on the spindle and you'll see it start to spin. Here we go. Looks like it's spinning, and we can just reverse that, M3S0. It should turn off. So we've tested out the spindle through the software. Everything's looking good. Nothing left to do but slap some material down on the board, get a file set up, and see how it runs. So I'm gonna put the 65mm dust boot back on from FoxAlien. It is a fairly snug fit, but got it kind of in a position where it will work. And then we're gonna drop in a 1/4" downtown Jenny bit using those 2 wrenches. You wanna make sure that collet is nice and snug. And I'm gonna go ahead and use this is some light duty double-sided tape. I'm gonna put that in the center and then add some clamps for good measure. So first thing I noticed is that there wasn't a delay to let the spindle come up to speed first, but it seemed to work pretty well. It's making some good chips, and once the spindle was up to speed, it was cutting pretty well. So we're gonna go ahead and let this file run. And I'm using a Festool shop vac into the dust boot. It's gathering a lot of the chips, but I couldn't get the boot down quite low enough. So on the top cuts, it's floating, but as you see, as it works way down, it's actually getting beyond the surface as far as pushing the bristles in. But everything's working okay. Everything's running all right. And we'll just let this finish up. I'm cutting out a couple of these bottle opener files. I customize these a lot. They're a pretty popular item. So here we're gonna just do a little quick cleanup of some of that dust that it didn't capture because that dust boot was sitting up. And I'm gonna remove the clamps. And then I honestly have a little trouble getting that double-sided tape off. So a little bit of a chisel probably up underneath that, just not digging into the spoil board. That will pop right off. And there you see the cut. I didn't quite go all the way through, so off to the sander. So I often leave just what's called an onion skin on just to kind of keep it from ruining the spoil board and splintering the backside. So I've got a drum sander, making use of it here. Just gonna ease into that. You see it's just starting to come through, needs a second pass. and that one gets that onion skin popping off. So we can pull these out, see that they're still just a little rough cut. So we'll add a round over at the router, being careful with the push blocks to protect the fingers, and get that center spot as well. You see we got just a little bit of extra burning, probably need to replace that router bit. So just a little bit of a hand sanding left, and we'll be ready to finish these. And so there we have 2 bottle openers, just a little bit of sanding. I'm going to need to finish these yet before I fully mount the metal plate in there, but that'll drop in. And so the CNC with the spindle completed both these for the cut in 5 minutes, 20 seconds, which is pretty nice. I could load up the whole bed with a bigger piece of material or multiple pieces of material and just let this thing route out, and it seemed to perform pretty well. One thing I do need to do is go ahead and add in a pause command. By default, the Vectric Post Processor didn't add one in, and so you just need to run in there to whatever your post processor is, or even edit your G code afterwards. You're going to want to add in a G04, which is a dwell command, space P, and then 10 or 15, however many seconds you want it to pause. That'll give the spindle time to spin up, stabilize the RPMs before it digs into the wood. So that'll be something else I need to add in, but it's going to be different on each of your software, whichever you're using to produce the G code for the machine. So that would be the final step in getting this set up. But it ran really well, ran flawlessly, I feel. Driving that 1/4-inch downtown Jenny bit through some hard maple, cut out a couple of these bottle openers that it's just an item that I tend to sell a number of. All right, so wrapping it up with the FoxAlien spindle upgrade, what are my thoughts? Well, it really went together pretty smooth. I think that most of the time was just getting that cable through that cable chain, but the fact that they have the kind of the split open design on that cable chain makes it fairly easy. The nice thing is all the wiring is done for you. Everything's kind of plug and play. The mount works pretty well. Their stock dust boot works okay. It fits on there. It's a little more snug than the trim router I had. And where I have to have this up, there's not a lot of extra room to bring it down. So that might be some custom item to add after this to get it just a little more movement on the dust boot for getting the bristles down onto the material when you need it. But other than that, it works. It works well. You could add this to really any of the GRBL based lasers that have, or CNCs that have the laser output, be it FoxAlien or some of its the other brands like it. And so the ease makes it easy. Now, could you do this for a little bit less on your own? Sure, there are kits out there for a similar size spindle, and you could do the wiring and figure out how to plug it into the controller, and you might save yourself, you know, another $100 or so. But ease and knowing that it's ready and set up to go might be what you want to go with for this one. So if you want to plug and play, drop it in, have it work pretty easy, you could probably do this whole install and setup in half hour, 45 minutes, just depending on how your wiring goes, and be ready to go. Or you could spend some time programming a VFD, making sure you got all the wiring right, getting the control cable right. It's your time or your money. And in this case, I'll take my time over the savings. But that's a decision you're going to have to make for yourself. So that's where I'm going to wrap this up. Hopefully this gave you a little insight on how this works, how to install it. And if you are interested, I will have links down below where you can pick up this spindle kit for yourself. There will be affiliate links, so I do get a small commission out of that, and it does go to help this channel. So I appreciate you using that if this did help you out. Otherwise, just happy to give you some more information, maybe help you make a more informed decision on your purchase for your shop. So thanks for watching this. If you have any questions or comments, go ahead and leave them down below. Tell me what you think about it. Tell me what maybe you would do. If you found it useful, hit that like button. And if you're new here, hey, consider subscribing. All that goes towards to help the channel. Once again, thanks for watching this video. I hope you found it useful. I hope you found it educational. And I hope you get out into your workshop and make something too. We'll catch you next time.